Alright, looks like we are up. Hey everyone, welcome to the stream. Today I'm going to do a mix of gameplay and some R Studio kind of stuff. So I've been playing around with writing blocks into the game. And so this is a mountain range near where I live. And so this is based on sort of natural terrain data that I've converted into some chunks for Minecraft. And so I'm going to kind of play with this data a bit today, jumping back and forth. I'll probably keep the sort of height map as it is, but I'm going to play around with the blocks and stuff on here and work on some of that code. And just thought I'd do it while people were watching. Yes, David? Sorry, I had to speak to my son for a second. Close the door. Right. Of course, he picks right when I start streaming to come ask me a question. Alright, so yeah. So, this is some terrain. Let's see if anyone else sort of shows up. So give a chance for more people to show up, and then I'll sort of go back and forth, because I can't have this world sort of active while I'm trying to, write to it, and I can't really do much. So I'm going to share this off a bit more, and then I'll switch back to RStudio. So if anyone has any questions or anything, feel free to ask in the chat. Sort of welcome all of you to chat. And let's see how today goes. Am I going to make a resource pack that will give a wider range of colors? No, probably not. I mean, if someone has a resource pack with a wider range of colors, I guess I can pick blocks from that resource pack and make it work. But for now, I'm just trying to stick with normal blocks and see how well it goes. So basically, the first thing I'm going to do is when I go back into the code, is I'm going to make this world. I'll show you like the process I go to get through this, and I'm going to try to replace the clay that this is using with something we're more used to in Minecraft. Grass, dirt, and stone. I want to see how that looks. And I have a larger world, so I'm go ahead and make the world larger and add some more bells and whistles to the script. So that's what my plan is. Feel free to ask questions and stuff as we go along. So I'm going to exit out of this world so I don't screw things up. Alright. Let me switch over. Okay. So let me get my yeah, so I'm in. Let me get my, let's see. Let me get set up to do some work here. So I'm gonna do my, let's see. Yeah, working directory. Okay, so I'm in the right working directory. Yeah, I need to update Stringer. I knew I probably should do that. Update Stringer. I just installed some new things on my computer, and usually what that means is I need to yeah, let me try this. So usually that means I need to like rebuild Stringer. Let me pop over session, restart R. Let me get a fresh session that has nothing in it and try to update it that way. Alright, so we don't like that. I need to force this. Not install. Update packages. That's what I really want to do. Update packages. Stringer. Force. Force. What's the helper? Update packages. Let's see if I can do update packages. Check. Nope, I did not do it. Need to force this. Quick Google check. Force rebuilding of our package. So what I'm having to do here is Stringer relies on actually no, it's not Stringer I need to do. I need string I, which is what Stringer depends on. Nope, it's not doing it for me. What do I need to do? And so what I need to do is, so I updated a library. This library here that Stringy needs. And so it's gonna take me a second to get the command. 'Cause usually it's fine. I just update the package because there's a new version. But there's not a new version. So easiest thing is I can probably do remove packages. do it this way. And then install it. So this will recompile it. Once I do this, I'll now be able to load it. This happens a lot, and usually I take care of it before I do something like stream. But so this will do it. So how's everyone doing today? See, while that's running, let's get an R script, and then let me open the file I was working on. So now hopefully we can do this. Dev tools. Load all. Okay, so Bedrock is loaded. I'm gonna load the other packages we're gonna need. So Tidyverse you've seen before. These other three are, whoops. Which one don't you like? Alright, so it looks like I gotta update another package. Remove package. SF. Oops. Remove packages. SF. So this will hopefully work. And we'll get going. Yes, let me know if you have any questions. Yeah, so I'll work you through the code while this is going. Let me smooth this over. Yeah, so what I need to do here is I have to give the latitude and longitude of a square I want to download data from. And so that's what I'm doing right here with this, constructing this data frame. So this is giving me sort of the X and Y coordinates that I want to pull data. This projection here, so this is creating a projection that kind of tells what sort of globe, basically it connects the coordinates to a model of the Earth. And this is a little bit cryptic, but it's the WGS 84 model of the world. And the next command, get elevation raster, this pulls elevation data based on these coordinates and this model and this sort of magnification. This gets at about 9 meter resolution, 9 to 10 meter resolution, from my understanding. And then our next step is we're going to convert it to a different coordinate system that will give us like units in meters locally. So that's what this line is doing. It's projecting it to a 4 meter resolution using a different coordinate system. And that gives us sort of our data. So once we get everything installed, let's see. So that's good. That's good. Okay, so this is another one that I need to update. I literally just updated my computer right before I did this stream, so I'm not surprised I'm having to do this. one. So hopefully this will work. And basically, because I'm working with GIS data, three-dimensional data, there's a lot of external libraries that the R's sort of link. Yeah, someone dislikes everything I do. Someone's always leaves a point. I don't know who is mad. I mean, yeah, so Jerry Plays, who says that someone already left a dislike for this. Yep. Okay, let me make sure I have all of these. Let me reset session. Restart R. I'll do a new R session. Let me see if this works. So, whoops. Okay, so that's good. Alright, I think I'm good. Let me also do RBedrock. Let's do a local version. So dev tools, load all. Alright. So I think we're good. So the first thing I'm going to do is I'm going to pull the data. Because I didn't actually save a copy of the height map last night. So I need to pull one into memory. I'll save one. This time. Alright, so I load the data frame, construct to the projection. I'm going to fetch the data. This is going to actually go out and download data from the internet. I believe it's going to use a service that's hosted on Amazon Web System, and then it's going to construct our projection. Then right now I can do this right. So if I do plot dat, should show up over here. You can see down here the projection of the height map. So this section kind of right here is what we saw earlier in the stream. Only this corner. I have like all of this that we're gonna try to do today. So now I'm gonna project it. So that's this next line. That'll take a bit. So that'll convert what I have now to basically a 4-meter resolution. So every pixel in this corresponds to an estimated 4-meter resolution. So it's kind of going to blur it out because the raw data I think is at best 9 meters, but it ends up looking good. So and in this model, 1 block in Minecraft is going to be equivalent to 4 meters. So mostly that's based on how much height range I have here. If I had shorter terrain, I can maybe go up to 1 or 2 ones, but when you have a lot of elevation change and you only have 256 blocks to work with, you're kind of limited on if you want to keep scaled resolution. So now these are my pre-coordinates that I figured out last night, and I'm going to use that to do a trim. So this is sort of the setup. I'm setting my bottom point down here, and from the projection, and now I'm setting up the bounding box, and then I'm going to crop my .m based on the bounding box. So that's what the next command's going to do. And then I'm going to adjust my height so that it is within the scale. And so that's this. Then if I plot it, you see this is the mountain I'm going to work with. It's taking me a lot to figure out all of this and get it to where I want. It's often like getting the crops right and stuff is the hardest part, making sure that things slope, because like down here it's now around 0, and the very highest it's now I believe like 250. So so next step is I'm going to create a matrix. And then rotate it. So now I'm going to go ahead and save this data later. I'm trying to see save. Trying to remember the yeah. So I'm gonna save XY file equals. Let's save it to my temp directory for now. This is Flatiron. So just in case, although that was pretty fast, I would do that. Okay, so that's the getting it into the data we wanted. And so let me show what I'm doing next. So so the way this works for the block writing is I sort of have a column from 0 to 256 of blocks that I want to put in, and it kind of defaults to hardened clay, but I do things like the lowest levels bedrock. I put some bands of clay in here, and now I want to do kind of the full model, the full terrain, and I'll walk you through how that works. But first, I need to get my dimensions of my XY. So my XY is a matrix with 2,400 blocks by 1,600 blocks. I divide these by 16, see how many chunks. So it's 150 by 100 chunks. So I'm going to change this here. So this is going to go from 0 to 149 on the X, and the Z is going to go from 0 to 99. So those will be our chunk coordinates on the X and the Z. I'm also going to set up, let me add progress. And then let me grab a note. One more over. Grab a piece of code real quick. I want it. Grab a piece of note. Scripts. And I want. I'll pull it from my mob spawner code. Back. Alright, so I'm going to do a progress bar down here. Load it in. Scroll back down. Alright, so I'm going to do a progress bar. Change. Total is going to be. That's 150 by 100. So now then, if I do it here, it works. Okay, so how does this work? So what's gonna go on here is we're going to go through all the chunks I want to write, extract out the height data for that 16 by 16 area, create a three-dimensional array that's full of air that goes from 0 to 255. And then I'm going to go through each of the points within that and fill in the column between 1 and the height the maximum height in the column based on our color column, our block column we did here. If I have time, I'm going to change this where it's a bit more sophisticated than what I'm currently using. Then I set up the chunk. I put the version value in. I write the subchunks using a new API. This API needs work. It doesn't work for all blocks, but it'll work for the blocks I'm using today. Then I set up the height map in the biome. Right now I'm using plains. Let me switch that. Let me use Mesa. Let me change this to Mesa. Quick jump down to see the Mesa biome. Let's go 37. So we use Mesa. And then we set the finalization tag and I update the checksums. Finalization is a tag that the game puts in that indicates like whether the chunk is done rendering, whether the chunk is done being ticked and saved and stuff. So I'm going to go ahead and put that in, and then I close the database. So we'll run this and we'll see how it goes. Right, no errors there. Creation of the progress bar. Now, one thing you gotta make sure I remember to do is I close the database before I go back into R. So go back into Minecraft. So if I then run that, oops. What don't you like? You do not. Is it H? What have I changed that you do not like? Is XY wrong? What is H? H is here. Which one is the closure? Oh, call. Oh, do not do the call. That'll definitely make it where it doesn't work. All right, start again. So this is why if you look at the bottom, you'll see sort of my progress bar as this builds the terrain. So I added this because it's nice to sort of see how long this takes. And once we close the database, we'll go back in and load it and see how well it does. And then we'll see how we're doing. Yeah, so I'm hoping to do more. The problem is once you start copying terrain in, the worlds get huge. Like if you really want to do like a life scale representation of X area, it's gonna get big pretty fast, the world, and it's hard to distribute that, right? So it needs to be something sort of clever. Because like a fully generated 4,000 or 8,000 by 8,000 world is like a gig. And I've done some of these prep in that, I mean, I'm looking like 32,000 by 32,000 to get something that's even a 10-to-1 representation of something I'm looking into doing. So I got to figure that out. How to trim some of the stuff down. So 41%. So we'll see how this looks. It's not going to look that different than what we had before, but it will be larger. So I want to see what that's like. And then we can come back and try to be smarter. You could, I mean, I could potentially make this run faster by batching everything. But I think most of the time is spent just the large world. I mean, I'm putting in 100 chunks by 150 chunks. That's a lot of work. I guess this is a 32,000 by 4,000 world, 24,000 by 32,000 world or something like that. 1600 by 2400 world I'm writing in here. All for like part of a mountain. So this is going to be pretty big. Several hundred megabytes that I'm writing. Actually doing more because I am putting in all the air blocks that the game would usually get rid of. But I'm writing those in because it's easier for me to do it, because otherwise I'd have to like delete them if they happen to exist, which I may do. But I'm just sort of letting the game take care of that when it resaves data. We're at 80%. That's good. So if I decided to, say, create a realm with terrain like this, would anyone be interested in playing on that realm? It'd be like a creative realm, since you can't really do survival. There's no survivalness. Not like I'm gonna anytime soon have code to put in ores or caves or anything. 94%. Done. Alright, close the database. Do it again, just in case. Alright, let's go see Minecraft. Alright, back to Minecraft. Load the world. So Blurryface asks, is there a way not to distribute caves and ores normally just on the new terrain? The new terrain is like written in, so I'd have to write if I wanted. So two different ways to do it. I can do this in a non-flat world, so people can go outside the new terrain and do their normal things. I could write a music's off. Let's see. What do I want to use? Let's do this one. I mean, I could, there we go. Now I can see what it's doing. You know, I could use like Perlin noise or something to make caves myself. It's like three-dimensional correlated noise to make caves, which is kind of like what the game does. Yeah, this is looking good. And I can do certain things like write ore generation code or something to stick things in here. Or, locate this, take this to create an island, stick it in a seed that has like a giant ocean somewhere, and do that. So what do you think about the terrain? I mean, we didn't have that earlier at the beginning of the stream, so it definitely looks way better now that we added the additional blocks. I mean, yeah, so Blurryface asks if the script relies on topographical maps. Yes. I mean, what I just did is I pulled topographical map data. Technically, you don't have to use a topographical map. You could use any sort of height map you want if you want to simulate one or not. But yeah, I found that doing stuff using real data definitely puts the I do not know if the height map data for New York City includes buildings. I don't know how they do that. But yeah, technically if you had a height map of all the buildings, you could, generate them if you wanted to. Or even use models using similar block writing techniques.
Didn't care for one another, you and I.
And so the question is about building something like a Burj Khalifa and Minecraft being too high. Technically, these mountains are too high as well. So this is a 4-to-1 representation of them. Get over here and look back.
Thought I'd still be feeling same as the beginning. Waste of time, waste of time. Somehow you intruded, lost in your illusions. I was fine, I was fine. You got me high, but I'm sober.
It'd be nicer if my chunks loaded faster, but they're just not loading fast. So, is it possible to do this in Minecraft Pocket Edition? Like, I'm in Pocket Edition right now. Now, is it possible to write your own terrain and use R just on your phone? No. But, you know, this is a... technically, the client I'm using is an Android client. I'm just running it on Linux. It's going to be fun is when the holiday update comes out and I have a lot more height to work with. I mean, I guess technically I can add more height to this thing, so for streaming easily. I can take it up to 512 if I wanted to. Similar to how you can build on the Nether. So what? So Blurry Face asks, so why am I using an Android client? That's what the Linux loader does. So I'm on Linux, and there's a loader. And what it does is it takes the Android x86 version of Minecraft and sort of wraps it in a way. This looks nice. That it can run on a Linux operating system instead of an Android OS, because Android is derived from Linux. But there's some things. So yeah, it's gotten harder and harder over the years, I think, to get everything patched and working, but it kind of mostly still works. So it's gonna be a sad day when keeping track of everything is just too hard. I'm gonna have to make a decision about whether I build Windows-based. What's over here? Let's let these load in. Come on, chunks, load. What I'm saying is, this is nice. Definitely pretty good terrain copying. I wouldn't say it's terrain generation since I copied it, but yeah. It really didn't take that many lines of code to do this, did it? Alright. Let's go back. exit out of the game. Let me get back to the... Let me just teleport myself. Yeah, I guess I haven't shown you what it looks like for someone on the ground. If you're just joining this stream, so what I am doing is I am pulling height map data, elevation data from the internets, and writing it into Minecraft to create terrain. That's what this is. So this is a mountain range called the Superstition Mountains near Phoenix, Arizona. And this is a 4:1 replica of the terrain based on interpolated data. Interpolated elevation data. Let me come back over here. Get ready. So I'm about to exit out and mess with the terrain generation. And I'm going to regenerate some of the chunks, not all of them. Kind of just our first part. So, saving and quitting. Make sure the world gets saved before I rewrite it. We go back to our studio. Okay, so what I'm gonna do next is, so I'm gonna comment this part out, and then I'm gonna change this. I'm not gonna do all of them. I'm gonna go back to doing it. Let's do a 30 by 30. Let's do a 31 by 31. So 31, 31. Here, let's go. Let's specify my dimensions. 30 on the X. 30 on the Z. X times NCZ. We're gonna do 1 to NCX. And subtract 1 from all of this. Do the same down below. Let me go ahead and source that before I forget. Move this down here. We're not going to source that one just yet. All right, so what I'm going to do now is I'm going to change it where the highest block is dirt. The next highest block, or the highest block is grass. The way to do that is I'll do B. We're just gonna do, I'll just save this right here. Double H is equal to HXC. So the highest block here, Z. We're gonna set that to grass. There, let me write. So that's gonna be okay. Below that, so we're gonna do BX. Do a sequence -4. So that would be, if I do this right, just temporarily, test. Sequence HH -4 to HH -1. 6, 7, 8, 9. Great. Do Minecraft Dirt. Should be fine. If not, we'll find out. I think it's dirt. I might as well do it right. I think it's dirt type equals normal. Real quick. Block states. Normal. Yep. Instead of course. And then the next thing we're going to do, below that, we'll do stone. Step to 2. Sequence 2 to. We're looking for HH -5. Z. Stone at stone, and then we'll do BX1 Z. We'll do bedrock. So what this means is 1. So the chunk is going to have bedrock, stone, and then 4 layers of dirt, then grass in every column, and then air for the rest. All right. So if I do this right, HH grass, HH -1 to HH -4, normal. 2 to -5 stone. Everything I think I'm going to do, so this could have an issue if our heights are not in this. I gotta think about this. Build it up. And then let's see, what if I do sequence 2 to 1, 2 to -1? I won't do that. If 2 just make sure that's what I want to do. Make sure this is not gonna don't want to do all this and then get into an issue where the height maps. So how do we do this? So top block we want to be grass. Lowest block we want to be bedrock. And then let's see. Int want something to be 0 if... Let's see. I want to try. I want to do... Let's try it. I think I should be fine for the height for this region. I'll have to think about it later. How to do this. Alright, let's see if it doesn't complain. Alright. Let's run it. See if it complains. So Fak asks, will mob farms work on the nether roof by increasing build height limit? Yes, they do. With the one caveat is nether mobs are cave mobs. So you gotta make sure that your mob farm has a roof on it to spawn anything. So if you just put blocks, and bedrock's also not a spawnable block. So you basically have to put 2 layers of blocks above the floor, the roof of the nether, to get anything to work. That's often people forget that. And they wonder why it doesn't work. Alright, let's try it again. Back to Minecraft. Oh, we're in. Looks okay. I mean, things are a bit weird because it's... Now this is weird. Why is it this way? I mean, it's a different biome, but... That's weird. I don't know why on the angle it's doing that. It should all be mesa biome. That should be the same biome. Unless I did something wrong. And it's not even full block. Weird. Biomes are weird. Maybe it's a flat world issue. It doesn't load everything correctly. Or it's a height issue. I don't know. It's definitely weird. These all should be mesa biomes. But yeah, I'm getting definitely a whole bunch of different colors of things. I'd have to go back and look to see what the biome looks like in this world. I'd expect to see grass color that's more like this, kind of savanna-ish. But not like this. It's possible the biome I picked has really messed up grass. Because it doesn't really have grass. They don't ever look at it. Probably should do plateau. Mesa plateau would probably do better. shaders, like grass or something. Alright, so what do you think? Dirt and grass, or this kind of terracotta hardened stained clay? What's your opinion? Give me an opinion in chat, please. What do you prefer? Got one vote for clay. Here's a good contrast. Guess I could use wool. I tried putting sand in earlier, just didn't look good with the terrain. I need to true, I did use just like having like lines of terracotta look okay. I need to sort of rotate them so they're not completely perpendicular to the ground. But the what's it, terracotta? But when I added in like sand that just had like an elevation thing, it just didn't work. It's also that I did it up too high. I need to figure out how to like measure slope of things so I can get a handle of when the elevation really starts kicking up, and that may help me do some more complicated terrain. So really, like all of this down here would be like dirt and gravel and stuff on top, and some grass and some sand. But then once like the mountains pick up, yeah, they should change. And so I need to like do something to figure out like the slopes of things. I don't know what the best way to do that is right now. So 2 votes for clay terracotta. Anyone else have any thoughts? Or any ideas? So Scarcraft asks, what chunk packer are you using? I'm using Theta Sigmas. And since I'm not actually on Render Dragon, I can still use it. I mean, these dirt mountains might look better if they weren't all grass. That's my take on it. If I had, like, I don't know, if I actually put in plants and trees and stuff, this would probably look better. Blackstone. Hey, that's a good idea. Blurryface says recommends I try to use Blackstone. In certain parts, yeah. Mix it in some Blackstone may work. And basalt. Alright. Let's try that out. Let's make sure this saves. Okay, good. That's been saved. Yeah, back to the code. All right, that was an idea. Let's comment these. Oh, let's go back to the height-based one. All right, so we want to use let's do let's try color. Let's go 90 to 99. Let's see what Blackstone is. That's Blackstone. Alright, so let's do something. So we did some Blackstone. And I'm gonna do one little thing so we're not walking around on Blackstone. Here, we'll do now then if B X HHZ is equal to Blackstone. So if the highest part of our column is Blackstone, we won't do that. I was trying to think like how to make it where it's not the top, but we'll try this. See how it looks. Alright. So all these, we'll keep these the same. Double check that it's not running. Let's run the next one. Yeah, so Sierra, thanks, Blurry Face, thanks for the idea of using black stone as part of the palette. So I'm already doing blocks based on height. That's the original one. That's how I get the bands. What I want to do is I want to have like a slope detection where I can maybe tell whether I'm on like the valley versus going up, and where it's not necessarily based on just height map, because like the slope changes. Certain parts, as we saw earlier when we were flying around, certain parts like the valley floor is higher than other parts. And you have the mountains that come up, and it didn't look good doing like a straight like sand everywhere. Below a certain area. See how Blackstone looks in the palette. May have to end the stream soon. We'll try another thing and see how this looks. Okay, we are back. Let's not take... Oh, I forgot to regenerate the colors. So all that waiting. Gotta redo it again.
No, anyway, what you were seeing back there was the superstition house. As you can see, my father's.
Gotta speak a little louder, Davey.
My father tries to does cool stuff he's with.
Okay, now let's run this again. Thank you, Davey. Oops. I did not get back to the cave. You're just looking at my Minecraft. So yeah, so let me get this rerunning. And then let me make sure I close the DB again. Oops. Let me do the whole thing. Oh, let me run this again. Just that should be good. Okay. Don't think that would have made any corruption. So let's try again. Hopefully.
Hopefully.
Thank you, Davey. There we go. There. Let's see what this. There's some black stone.
Yeah, just more. This mountain
driven out there before.
They're tiny.
But yeah. So that's, I don't know if it works as a band. Using Blackstone. Maybe a smaller band like the white.
Wow. That is really incredible, Dad.
But let me look up. Let me see. Wait for the mountains in the distance to pull in. That's the best part.
I kind of still do remember a bit of the mountain range, but I still don't have a clear image of the
Yeah, well, it's not as jagged and it's much more smoother than the actual mountains because of the resolution. Can't really get, you
Oh,
know,
I'm talking to my brain.
you're talking to your brain. Okay.
Let me see. Hey, I like the Blackstone band.
Yeah, I think it works, but I think it's a smaller band would probably be better, like the white one.
Yeah, I kind of remember, and I kind of.
Well, the bands aren't out in the mountains themselves. This is an artistic impression of them.
What up, friend?
Nothing's gonna print. We're good. All right, so I think my kid's in here because he needs me. So I think I'm gonna end the stream here, and go take care of some stuff. But thank
Will
you.
you lost the world? We live in Arizona.
Yeah. And yeah. So I gotta go take care of a few things. So thank you all for participating. I hope you've had fun. I hope you've learned something. So like if you have any questions about this, please join my Discord, ask, and I'll be happy to answer your questions. All right, bye.